My name is Dr. Shahal Rosenblatt. I am a developmental neuropsychologist specializing in the assessment of treatment of children and adults who present with various medical, neurological, and psychological difficulties that impact their ability to function on a day-to-day basis. The focus of this presentation is math-based learning disorders. Picture a school-aged child who is struggling with math. She doesn't understand the facts and procedures involved. She cannot decipher word problems. At home, she spends hours on homework. Her work tends to be messy and disorganized. Oppositional behaviors arise, and she fights to complete schoolwork. What is causing these problems? The behaviors we're witnessing are really a cry for help from a child who wants to succeed but often is unable to for reasons beyond her control. Before continuing with our discussion of mathematics disorders, I'd like to briefly discuss what neuropsychology is. So neuropsychology is a branch of clinical psychology that studies how the brain and nervous system affect how we function on a daily basis. Unlike the use of imaging techniques, for example, MRI, CT scan, and EEG, where the focus tends to be on brain structure, the neuropsychologist seeks to understand how the various structures work together and how that impacts our ability to do what is expected of us on a day-to-day basis, whether in school, at work, or with one another. Clinical neuropsychology makes the use of various assessment methods to ascertain function and dysfunction. And through these assessment techniques, we gain an ability to understand the individual's areas of strength and weakness and help develop rehabilitation plans, methods of increasing and improving functioning, and providing the appropriate services that are necessary to be more effective. Returning to learning disorders, it is estimated that they impact approximately 20% of school-aged children. Learning disorders are typically diagnosed when the individual's ability in reading, writing, or math are, for children, below grade-based expectations usually. For adults who are out of school, they're diagnosed when the ability in each of those domains is below what is expected for their age. In addition, it's important to note that the disability affects you depending on what type of environment you're in. So for children, this could involve academic weakness and failure. For adults, this could involve taking a job that avoids the particular area of weakness or taking a job that is below their ability level. So for instance, you may have someone who is brilliant with their hands, but because they can't read or write or do math, instead of becoming architects, they do something that is not quite as skilled. The Diagnostic and Statistical Manual, 4th edition of the Psychiatric Association, was first published in 2000 by the American Psychiatric Association. In that version of the Diagnostic Manual, the learning disorders were divided into 3 subtypes: reading disorder or dyslexia, mathematics disorder or dyscalculia, and disorder of written expression or dysgraphia. It's important to note that the prefix dys, dys, refers to a disorder that is developmental in nature. For example, dyslexia means that the individual was born with a disorder that prevented them from learning how to be able readers. In contrast, alexia, acalculia, or agraphia represent similar disorders that are acquired later in life. And so, for instance, you may have someone who suffered a head injury, stroke, or a brain tumor that affects specific brain regions, leading to alexia, acalculia, or agraphia. In 2013, when the DSM-5 was released, the American Psychiatric Association subsumed learning disorders under a single diagnostic category of specific learning disorder, or SLD. In this and the subsequent 2 slides, we're going to go over the specific criteria needed to diagnose SLD. And these apply equally to math writing and reading. And so for the purposes of our talk, items 5 and 6 are the most relevant. So criterion 5 includes difficulty mastering number sense and facts. So for example, a child may count or perform calculations using their fingers when there appears no longer to need to do this. Or they may perform the incorrect arithmetic operation, such as when they don't know how to subtract, so they end up adding instead. Criterion 6 involves difficulties with math problem solving. And so this includes the ability to follow the steps needed to problem solve, figure out what is required to complete the process, and use the proper procedures to arrive at a solution. The components on this slide ask the basic question: when does a learning difficulty reach the threshold when a learning disorder can be diagnosed? As noted in B, to be considered a disorder, the difficulties in math have to be substantially below what is expected based on the individual's age, and the deficit has to cause significant difficulties, whether in academics, vocation, or in daily living. Typically, learning disorders are diagnosed during school years. However, the current criteria state that formal testing during those years can be substituted for using documented deficits if formal testing is not available. So it used to be the case that adults were disadvantaged when needing or requesting accommodations because they couldn't prove that they had a learning disability, as they were never tested. These days we're more likely to test, and so kids are more likely when they grow up to have some type of documentation stating so. For C, the difficulties in learning begin during school years, but it's important to note they may not manifest until demands for those skills exceeds what the person can do. So if the deficits don't impact functioning, then we cannot call it a disorder. Criterion D refers to the fact that the learning difficulties have to be associated specifically with, in this case, math, but also in reading or writing, as opposed to being caused by some other issue. And so, for example, if you have someone with an intellectual disability, in order to get a diagnosis of a learning disorder, in addition to that, we have to show that the learning difficulties exceed what would be expected based solely on the learning disability. And so here we're looking to do differential diagnosis to make sure that it's a learning disability and that treatment would be for a learning disorder as opposed to something else that may be mimicking what looks like a learning disorder. In this slide, we see where the specific learning disorder is divided into the area that is most severely affected, whether in reading, writing, or math. And for our purposes, math is what we're interested in. When we're talking about impaired mathematical functioning, it could involve number sense, for example, knowing how to count or understanding that each number represents a specified quantity. Memorization of arithmetic facts is your ability to know that, for example, 4 times 4 is 16. You're not multiplying 4 times 4 or adding 4 times in order to get to it. I just ask you 4 times 4 and you just know the answer. Accurate or fluent calculation involves quickly retrieving math facts or rapidly doing the calculation rather than, for instance, using one's fingers to do so. Accurate math reasoning refers to knowing which operation to use, when to use it during a problem-solving procedure, and how to organize the problems and the steps that are required to arrive at a solution. So more statistics about math disorders. They appear to occur in about 6 to 7% of the population, with another 10 or so percent being labeled as low achieving in math, but not quite reaching the threshold necessary for a formal diagnosis. It's interesting to note that math disorders and reading disorders have a comorbidity of about 40%, meaning that about 40% of individuals diagnosed with a math disorder may also have a reading disorder. Now, keep in mind again that dyscalculia is when a math disorder occurs through a developmental process, while acalculia is when a math disorder occurs due to some acquired injury to the brain, whether a stroke, tumor, or otherwise. Although the research on math disorders is not yet conclusive, it points to 3 subtypes of math disorder, with each highlighting specific areas of impairment that impact math learning and application. They are the semantic memory subtype, procedural subtype, and visual spatial subtype. The semantic memory subtype commonly co-occurs with reading disorders and is characterized by difficulties recognizing the symbols and the quantities that they represent. And so, for example, why does the symbol here, 2, represent this many items and not this many or this many items? As with reading and the alphabet, there's nothing inherent to any of these particular symbols that says they need to equal a particular quantity. It is something that we humans have decided that they're going to represent. And so, like the letters in dyslexia representing specific sounds, the numbers represent specific quantities. Individuals with this subtype of mathematics disorder tend to have poor automaticity that is associated with an inadequate understanding of math facts and ability to retrieve that information from memory. Those who present with the procedural subtype of mathematics disorder typically have adequate quantitative knowledge and a relatively intact understanding of symbol quantity relationships. Where they struggle is in inadequate strategy use and a reliance on immature strategies. So for instance, instead of going back to our 4 by 4 calculation, they'll end up adding the numbers 4 times, which slows them down. Or they'll use their fingers to do simple addition and subtraction problems, again, slowing them down. As the number problems become too complicated for finger use, they may use counters or other strategies that can help them be more accurate, but again, slow them down. Or what you'll see is a lot of careless mistakes. With that in mind, this is the subtype that is most frequently associated with the inattentive subtype of ADHD. And so the points to keep in mind are a calculation process that is slow and may involve using immature methods to arrive at a solution, and a propensity towards careless errors when performing math operations. Individuals who present with the visual spatial subtype show problems with the organization of the math problems in space. So this includes difficulties aligning the numbers in columns, maintaining place values. These are the difficulties that are typically associated with the right hemisphere and are commonly found in children who were once diagnosed with Asperger's disorder, which is now subsumed under autism spectrum disorder. The research has shown that math disabilities run in families, which implicates genes. For example, Shalev et al., in a study of the relatives of children with math disorder, found that 66% of mothers, 40% of fathers, 53% of siblings, and 44% of second-degree relatives, such as aunts and uncles, also had math disabilities. In addition, the research on genetics of math disorders is still in its infancy. So we don't have that much data about specific genes, but the fact that you find concordance amongst twins and comorbidity with genetic disorders such as Fragile X, which we'll discuss later, Turner syndrome, 22q11 deletion, all of these implicate the fact that genes are a part of the cause of math disorders. In the next few slides, I'd like to spend some time talking about the brain regions that are involved in math function and dysfunction. So the semantic memory subtype is similar to an acquired syndrome that involves acalculia with alexia and agraphia, meaning that there's a disorder of math function along with difficulties in reading and writing. And these math deficits are specifically associated with an impaired ability to read and write the numbers. It is typically found in the left parietal regions, including the supramarginal gyrus, intraparietal sulcus, and angular gyrus. So continuing with our discussion of brain regions associated with math, the visual spatial subtype is associated primarily with right hemisphere function and dysfunction. Looking at the picture down here, the first row is of girls with normal developing brains. The bottom row are girls who have been diagnosed with Fragile X. Now, Fragile X is an X-linked disorder that in boys is associated with autistic features and mild intellectual disability. In girls, intellectual functioning can range from average to somewhat impaired, but it tends to be less severe because girls genetically have 2 X chromosomes while boys only have 1. So if you look at these two sets of brain activation slides, you can see that in the typical developing girls, the brain regions activated, it's fairly bright red across both the right and the left hemispheres. Switching over to the bottom row where we have the Fragile X girls, you see very little activation in the left and reduced activation in the right, showing that their brains are not processing the information in as rich a manner as the unaffected girls. So genes appear to account for between 1/3 and 2/3 of the variance, meaning that math disorders are highly variable. At this time, we don't know of any single gene or set of genes that is associated with math disorders, but they do share approximately 1/3 of the variance with intelligence. Another third is shared with reading disorders, and the final third is unique to math disorders. So there may be genes that are common to both math disorders and intelligence, math disorders and reading disorders, and then there may be something genetic that is unique to math disorders. So when someone comes in for a neuropsychological evaluation, especially if they're school-aged or they're planning on going on to college or grad school, academic assessment becomes an integral part of the neuropsychological evaluation. Specific to math, we're looking at 3 different components. Number skills for younger children can include things like ability to count. As children get older, we're looking at simple addition, subtraction, and multiplication, going on to algebra, and then to even higher order math like trigonometry and calculus. Math reasoning is our ability to formulate the problem, which means that you need to understand the specific procedure to apply, how to apply it, and the steps you need to follow in order to complete and arrive at a solution. And so this can include word problems, reading graphs, and other practical application of math skills. Fluency refers to the speed and efficiency with which math problems are completed. And in this case, during the assessment, we're not looking at your ability to solve complex multi-step problems. In fact, the math problems themselves are very easy and very few errors are made. We're just looking to see how quickly and effectively you attack these simple problems. And so the faster you are, the more automatic the calculation process is and the more efficient you become when solving math. Now, to be truly good at math, you need more than just math skills, and that's where the second half of this slide comes into play. So we have attention, working memory, spatial reasoning, and understanding of the symbols involved. Attention is your ability to focus on what you need to. So when you're given a word problem, for instance, not only do you need reading skills, but you need to be able to attend to the relevant information and filter out any distractions. Otherwise, you may miss important information or make careless mistakes. Working memory is your ability to hold on to information and manipulate it. And so when you're given a math problem, if you have to write down every single component, it becomes slow, inefficient, and very laborious. If you can hold the information in mind and process it that way, you're saving a lot of time and effort. And so the more effective working memory is in its application to math, the more effective you are at solving math problems. Spatial reasoning involves two things. It involves your ability to organize the math problems on the page. And so picture a subtraction, multiplication, or addition problem where it's multi-digit and you have to carry over. If it's not well organized on the page, it's sloppy, you're more likely to make errors. We also have graphs, charts, and more visual aspects of math where if you have difficulty with those spatial components, it's hard to make sense of them. Now, the ability to understand what the numbers and the operational symbols mean is similar to the way the sounds work when reading. If you understand that each number represents a certain quantity when it's in a certain location, then at least you've got the basics of numbers down. If you understand what the symbols mean, for example, a dash can represent subtraction, a little x can represent multiplication, you understand the basic language of math, and this gives you an advantage over someone who lacks these skills. So what are the implications of math difficulties? So when children struggle academically, it has a significant negative impact on self-esteem and motivation. And this can be partly due to grades, but just the level of frustration, the anger, the sadness that comes with not meeting expectations. But what impact does a math disorder have on adults? And this is actually interesting and why it is so important for us to become more effective at teaching math and remediating math difficulties. So in a 2011 review, David Geary reported research showing that women and men with math disorders in the US and Britain were less likely to be employed full-time, more likely to have low-paying jobs, and for women in particular, they were more likely to permanently drop out of the workforce. So in children, we typically think about it as, needing to pass school. But the long-term implications are much more severe in terms of overall employment, finances, and ability to just be effective day to day. My name is Dr. Shahal Rosenblatt. I am a developmental neuropsychologist specializing in the assessment and treatment of children and adults who present with various medical, neurological, and psychological difficulties. The purpose of this talk is to gain a better understanding of math-based learning disorders. We will go over the diagnostic criteria, some of the brain-related regions associated with the disorder, and conclude with some of the components involved in the assessment of math-based learning disorders.